Hey everyone, I hope you all are well. Today we will be in today's video we will be talking about how to graph a quadratic. Um, and to start off, there are various ways on how to graph a quadratic, and there's three forms that can help you graph a quadratic, right? And so, depending on what your teacher has taught you so far, we know a couple forms on how to graph the quadratic equation, ax squared plus bx plus c, and the reason that could possibly help you graph a quadratic is because it gives you the y-intercept, which is also one of the key points to graphing a quadratic. But that doesn't give you a whole lot of information. It just gives you the y-intercept, and your y-intercept is the c value. Um, Give me a second. Let me highlight it. This c value is your y-intercept. And so then that's one of this that's the first form, right? It doesn't give you too much information to work with, but in the second form, factored form, gives you quite a lot of information to work with. So it actually gives you your x-intercepts, which are major points, right? If there is any x-intercepts, right? Because you first have to figure out if there's any x-intercepts. And yeah, so this will work if there are x-intercepts. So it gives the x-intercepts and it gives this a value. That a value can help you graph, sorry, my bad, graph using step method, which we are going to go over today. And finally, in my opinion, one of the most effective forms also is number 3, vertex form. And what vertex form helps you do is it gives the vertex of the quadratic. And what I mean by vertex is, say you're given a regular parabola of y equals x squared, right? This is your y equals x squared graph, right? And the vertex in this case would be this point right here. That's like the origin. The origin in this case is the vertex. So the vertex coordinates would be 0, 0. Right? H and K, right? So those H and K values that after doing as a set of steps to get into vertex form, it will give you your vertex values. Um, and how you get into vertex form is by a step or a method called completing the square. And I'll talk about how to complete the square in order to get into vertex form. So vertex form and factored form are the primary ways on how to graph a quadratic. And that's basically what we've gotten to so far. And what we also have to understand is that in a quadratic, there are transformations, right? Because with the transformations, it tells us if the parabola goes left, right, up, down, and if it stretches, if it's going to look very skinny or if it's going to look very wide, right? So that's what even vertex form, right? In vortex form, it tells us what the transformations are, and here I've listed them. So for the a value, it tells you the vertical stretch slash compression, and if a is greater than 1, then it's going to be a vertical stretch, right? So if a is greater than 1, so if a is 2, right, that means it's going to be a vertical stretch if it's anything above 1. But if a is greater than 0 but less than 1, then it will be a vertical compression. So it has to be greater than 0 but less than 1, right? So if your a value, for example, is 1 over 2, that equals 0.5, right? So therefore it's going to be a vertical compression, right? Not that hard, fairly simple. Now moving on to what the h value gives you. The h value gives you the horizontal translation, and that's basically left or right. So if it's negative, right? So if it's the weird thing about horizontal translation is that when it's in the bracket, right? When we have x minus h, right? Because here is x minus h, right? Once we take that h value outside of the bracket, it's going to become positive. Okay, so the signs change, And the same goes for if it's positive inside the bracket. So if it's x plus h, that means when you take it out, it's going to be negative h, right? So when you take it out and it's negative h, it's going to go left. When you take it out and it's positive, it's going to go right. So if I have something, for example, that's like x minus 4, that means it's going to be 4 units to the right, right? If they were asking you to describe the transformations, 4 units right, right? Um, and yeah, that's basically for horizontal translation. Now with the vertical translation, it's just up or down. And this one, it's not inside a bracket, right? It's just k, right? Plus k. So no signs are going to be changing. If it's positive, it's going to go up. If it's down, it's going to be negative. Pretty straightforward. And the last reflection you could possibly have is a reflection over the x-axis. And a reflection over the x-axis, man, I can't speak. A reflection over the x-axis is basically when your a value has a negative in front of it, right? And you have to remember that that negative is not part of the a's value, okay? It's just a negative that's there, and it tells you there's going to be another transformation. Um, and that negative only affects the y values. Because look, if that's negative a, right, and it's a vertical stretch, right, a stretch affects the y values only, not the x values. So if you, for example, have a coordinate at 1 1, right, and there's a reflection, the reflection will only be affecting the y value, right? So if this is x and this is y, then it's going to be y negative 1, right? Because it's flipping. You have to visualize it a bit. If it's 1 1 and it's flipping over the x-axis, then it's going to be affecting the y value. So then it's just going to become negative 1. And that's basically it for reflection. Once we do more examples, it'll make much more sense. But yeah, that's basically it for transformations. You have a total of probably 4 transformations you're going to get to in grade 10, especially in grade 10 content. And that's basically it. And another one of the key things that also helps you graph is the step method. So, what is the step method, right? If you notice in a y equals x squared graph, right, it's symmetrical, right? So if I draw a line here, this is like the, well, let's stick a little. If this is the axis of symmetry, right? Because remember, a parabola is symmetrical, right? The left and right side are symmetrical. So then if this is the where I just dotted with the green highlight, if that's the axis of symmetry, right? The left side and the right side are the same. And so what happens on the left or right side happens to the opposite side. So what happens on this side, for example, will happen on this side. Okay? So the step method is basically when it's just like distance between the points. It's almost like rise over run that you've done in grade 9. So basically it's like this. You go 1 this way, 1 up. So one right, 1 up. Okay, it's just a pattern. The step method is just a pattern. And then it goes 1 right, 1 right, 3 up. That's a bad. 1 right, 3 up, right? And here I put 1 3 5 7 because that's what it goes up by. So you always go 1 to the left or the right, and then based off where you are in the pattern, you go 1 up, 3 up, or 5 up, or 7 up, right? So maybe it'll make more sense if I do it like this. So you go 1 right, 1 2 3. Oh no, my bad. You go 1 left, no, 1 right, 1 up, right? 1 right, 1 2 3 up, 1 right, 1 2 3 4 5 up. Okay, so then you're gonna have points here, 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 and here. Okay, that's basically what I drawn right here, right? Um, it's just a pattern that goes 1 right, 1 up, and then and the pattern can continue. You just add what you're going up by increments of 2, as you could see. So it starts off at 1 up, then 3 up, then 5 up, then 7 up. So then the next one's going to be 9 up, then it's going to be 11 up, then it's going to be 13 up. But you don't need that many points to help you graph, right? You just need like 3 to 5. So what I do is I just stick up to this pattern. I just stick to 1 right, 1 up, 1 right, 3 up, 1 right, 5 up. You can do the 1 right, 7 up if you have space, but you should just stick to 1 right, 1 up, 1 right, 3 up, 1 right, 5 up, right? And that's just for the right side. So for the left side, it's going to be the exact same thing, except going right, you're going to go left, right? And then, yeah, it's just going to be 1 left, 1 up, 1 left, 3 up, and then again 1 left, 5 up, right? And that's basically it. It's not that bad. Once you put into context, it'll make much more sense, right? So using the 3 forms that help you graph, right, and particularly just 2 and 3, because those are the things that will help you graph, we'll put into context now with transformations and the step method and apply it to some questions. Okay, so here's the first question. You can probably do this in multiple ways, but for this question, I specifically want to do it in vertex form, right? And this is the perfect opportunity for me to show you how to complete the square, because completing the square just has a few extra steps inside that help you get into vertex form, that help you get into the y equals ax minus h squared plus k form. So what you're going to want to do first is bracket your first 2 terms, not your last term. So you're going to do y equals 5x squared minus 20x plus 15. Right now we are doing the process of completing the square, which helps us get into vertex form, right? Now, once you graph the first 2, once you, wow, I'm speechless right now. Once you group the first 2 terms, you're going to want to factor out something that's common, but that is not x, right? Because x is common, but don't factor out x. You're going to want to try to factor out something that will leave you with 1 as the a value. So what is common here that you can factor out that is not x? 5. And when we factor out 5, it'll give us an a value of 1, right? Because if we look at this, I keep saying a value, but if you don't know what I'm talking about, x squared plus b x plus c, if it doesn't give us an a value of 1 here, right, then it'll make our lives much harder, right? And for grade 10 content, I don't think your teachers will do that. So when you factor out 5, you're just going to be left with x squared minus 20 divided by 5, 4x, okay? That's what you're left with. And then now the extra step kicks in here. So what you're going to want to do is, say you're with this 4, right? I'll do it as a separate step, even though I can do it in my head. You're going to want to do 4 divided by 2 and then square it, okay? That's what you're going to want to do. And then once you do that, you're going to get a value. So what's 4 divided by 2? That's 2. And then 2 squared is just 4, right? So then what you're going to do is 5x squared minus 4x. And then you're going to do plus 4 minus 4 inside the bracket, okay? So then you always do plus the number minus the number in the bracket, and then repeat what's outside, plus 15. And do y equals 5x squared minus 4x plus 4. And I'm going to stop here for a second, because what you're going to want to do is make this bracket into a perfect square trinomial, right? And if you remember from factoring, a perfect square trinomial must have a perfect square root of the a value and a perfect square root of the c value, right? So what you do now is you actually take out this negative 4, right? You take it out of the bracket, okay? And when you're taking something out of the bracket, there's another extra step you have to do. So you leave the plus 4 inside, you take out the negative 4, and you actually times it by 5. The reason you times it by 5 is, what did we factor in the beginning? We factored out 5, right? We factored out 5. So then when we take it out and we take something out inside the bracket, we have to multiply it by what's in front of the whole bracket, okay? Because we took it out of that bracket, which we factored 5 from. It's a little confusing at first, but once you just do the steps and the practice, it's not that hard. And then you, again, just put plus 15. Now, if you simplify this, you're going to be left with 5 x squared minus 4x plus 4. I'm doing extra steps just to show you guys. Negative 4 times 5 is negative 20. Negative 20 plus 15 is going to be negative 20 plus 15. That will give you negative 5. So then you're going to be left with negative 5 here. And again, like I said, you want to get a perfect square trinomial. And this, in all cases, you're going to get a perfect square trinomial here, right? And this will just be x minus 2 to the power of 2. So y equals 5 x minus 2. It's basically this, x minus 2, but we can write it as x minus 2 squared, because then look, it fits this format right here, x minus h squared. And that's basically it. Copy the negative 5, and then there you have it. There's vertex form right here. And with this information, now we are given the vertex of the quadratic. So the vertex will be, and remember, when you're taking out negative 2, that means it's going to be positive. So then it's going to be positive and then negative 5. The value for vertical translation stays the same, but with horizontal translation, the operation switches because you're taking it out of the bracket. So now that we have the vertex, what we can do is, here's a graph. We can make it real quick. Now, let's plot our vertex. So it's 2 and negative 5. It's going to be right here. Okay? So now, there's our vertex. And what can we do now, right? So there's multiple things we can do. We can either find the x-intercepts, or we can just use step method, right? If we use step method, right, remember it goes in the pattern of 1, 3, 5, right? So this is just all the values that go up, because other than that, you're just going 1 right or 1 left, right, the whole time. 1 right, 1 up, 1 right, 3 up, 1 right, 5 up, 1 left, 1 left, 1 up, 1 left, 3 up, 1 left, 5 up, right? Because it's symmetrical. What happens to the left happens to the right. And so what we're going to do is, this a value is very important, because remember, that's a vertical stretch and that's affecting the y values. So what we're going to have to do is actually multiply these values by 5, right? So that up value, which is this 1 value, right? When we're going 1 up, it's getting affected by a vertical stretch. So we're just going to multiply it by 5, right? So when we multiply it by 5, you're going to get left with 5, 15, and 25. And our graph's not big enough. It'll probably only graph that it goes 1 right, 5 up, right? So now these new values will go 1 right, 5 up. So 1 right and then 5 up. 1, 2, 3, 4, 5. So there's a coordinate right here. And we do the same on the left side. Automatically, it's going to be here because it's symmetrical, right? But if we do it, it's going to be 1 left, and then 5 up. 1, 2, 3, 4, 5, right? So now, usually we can just graph with 3 coordinates, and that will be fine. 3 to 5 is in the range of which is good. So then your graph will look like this. And make sure you draw arrows at the end, and then that's it. That's all there is. to graphing something using vertex form. If we wanted to go higher, right, again, 1 left, 15 up, so it'd be like 1 and then, oh my, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's going to go through my letters. But yeah, that's that, you get the gist of it. And that's basically it. And even by using step method, it gave us our x-intercepts. You see where our points are right here? These are our x-intercepts right here. So even using step method gave us our major points, which are our x-intercepts. And that's basically it for that. Now let's move on to this example question, which will be our last example question, because I have other practice problems for you to do on your own. But yeah, that's basically it. For this specific one, I want you to factor, right? And by factoring, we can actually still get the vertex, and you'll see how. So y, we're going to set it equal to 0. 0 equals x squared minus 8x plus 15. So then now we have to find two numbers and multiply to 15, but add to negative 8. Automatically, that's going to be negative 5 and negative 3. So then, if we factor it, we are going to be left with x minus 3, x minus 5. Now, what do we do with these values? When we actually factor a quadratic, and this is set equal to 0, we can actually set this whole bracket equal to 0 and this whole bracket equal to 0. So we can do x minus 3 equals 0, x minus 5 equals 0. Now, we can isolate for x in both cases, take them out of the bracket, so we get x minus 3 equals 0. I'm doing more steps than usual. You don't have to show this many steps for this. 0, and you're going to be left with x equals 3. And the reason 3 is because we remember BEDMAS, we bring this negative over here to replace the 0, because 0 just means nothing, right? It's just there. So when we want to isolate for x, remember you just bring it to the other side and the signs change. Just simple BEDMAS. And then we're going to be left with x equals 5 here. So now we know two of our x-intercepts, right? One of them will be at 0, 3. And one of them will be at 0, 5. So let me quickly label this. Now, we plot our x-intercepts because we know it's at 0, 3, and 0, 5. 0, 3, I'll use different colors. 0, 3 is right here. 0, 5 is right there. Now, we are only given 2 points now, right? The two x-intercepts, those count as points. So what you do now is you can, since we know that a parabola is symmetrical, right? That means if we cut it in half, exactly in the middle, we are going to get the x value to our vertex, right? Because here, right, our x value is somewhere in between 3 and 5, right? And where it is in between 3 and 5 is directly in the middle. And so what we can do is we know our x-intercept is somewhere here. Let me actually get a different color. We know our x-intercept is somewhere along this line. And the reason it's along that line is because it's the exact middle between 3 and 5. What's between 3 and 5? Number 4, exactly, right? So then that means we can just substitute in 4 into this equation of y equals x minus 3, x minus 5. And once we substitute it in, it'll give us the y value to our vertex, right? So the y value in this case will be, let's first substitute it in. So y equals, and then we substitute in 4, because that's the axis of symmetry, 4 minus 5. So then we are left with 4 minus 3 is 1. 4 minus 5 is negative 1. So now we are left with y equals negative 1. So now we know the vertex is 4 and negative 1 because when we substitute in 4, it gives us an output y value, which is negative 1. So that means our vertex is right here. And so now we can just use step method to find any other points. So if we do use step method, like there's no a value. The a value is 1. So in this case, if we use step method, it's just going to be the 1 right, 1 up, 1 right, 3 up, right? And so on. So it's going to be like this. So we already given the x-intercepts, which is the 1 right, 1 up. Now if we go 1 right again, and then 3 up, 1, 2, 3, there is going to be a point right here, and there's going to be a point right here. So our graph will look something like this. Whoa, I suck at drawing. It'll look something like that. Make sure you get your line to go through most of the points or all of the points. Your teachers might dock marks depending. But your graph will look like that, and you make sure you also add arrows at the end. Very important, because the parabola just keeps on continuing, right? Unless there is restrictions that you are given. And that's basically it. That's how you would graph these based on what you are given or what the question's asking you, vertex form, factored form. You could do this one in factored form as well, probably, but for this case, I wanted to teach vertex form if you did not know. And that's basically it. On the next page here, I have other questions also. And so let me quickly do it, and then, yeah. So I finished the solutions for these two questions that I gave you. There's various ways you can do them, so I did both of the ways, vertex form and factored form. That's basically it. For this one here, a little bit more complex because it's 1 over 2. And you use the same exact logic. If you were to use step method, you would still multiply them by 1 over 2 since that's the a value. And then you're given, decimals, but usually you'll get whole decimals. So if you're given decimals, you're going to want to kind of guess, right? So for example, the vertex here is -4 and -10, right? And with step method, it's going to be 1 to the right, but now it's going to be 0.5 up, right? So then I would have to guess, and you always have to make a scale that's good. I went up by increments of 2, so it made it a little harder. So if this is -9 right here, and I have to go up 0.5, that means I have to go up right till here, right? And that's where my coordinate is, 1 up, 0.5, right? And then with the other one, it's going to be 1 to the right and 1.5 up, right? And then 0.5, right, which is down here, plus 1.5 will give us a whole number, right? So it'll be right here. And then since we're there, right, since we're at -8, the next one is 2.5. So we're going to go 1 to the right and 2.5. And 2.5 will be 1, 2. And then remember, going up by increments of 2, so the 0.5 will be right here. And what you do on the right, you do on the left. And this is what your answer should have looked like. You probably could have went higher and gone to the x-intercepts, but there's no point if you have this many points graphed, or even like if you didn't even have these ones or these ones, it should still be fine. But yeah, that's basically it. I hope you enjoyed this video and learned a lot, and learned how to graph quadratics with various forms and methods and ways. And that's basically it. Take care, everyone, and have a great night, evening, or whatever time it is for you. Bye, everyone.